So every year I have to give the same spiel to my skripsie students to explain to them what goes into the skripsie report. So this year I thought, let's just do it once, then I don't have to do it every year. So a few things to note just before I start with what goes into the report is that firstly you need to understand that the report is the one thing that the examiner uses to assess your work. With the skripsie, there is no opportunity for demonstrating physically how your system works, and the examiner basically gets your report, makes a call on how much he thinks you should get, and the only thing that you can salvage after that point is really through the oral. So you want to preferably sort out everything in the report so that the oral is a rubber stamp, because the oral is really only used to answer questions that the examiner may still have after reading your report. So keep that in mind. The report is very important. The other thing to keep in mind is that the report is really there to ensure that you match the EXA outcomes, because that's, you will see as we go through the report, and if you go and read the EXA outcomes, the report to a large extent matches the EXA expectations to directly show to EXA that you have indeed achieved their exit level outcomes. So keep that in mind as well. All right, so looking at the report, you have a few sections, and these are general guidelines. Okay, it's not hard and fast, but it helps you maybe understand what to do and what to look for. So in section 1, which will be the introduction section, you need to specify what it is that you try to do and why you try to do that. So you need to set the scene, explain the context, and explain the objectives. So the first thing here is to capture the background. So in the first section in your introduction is, why does this problem matter? Why did you do it, and why is it important that it would be or should be done? So if you're looking at developing a water quality sensor, you want to explain how many people have issues with water quality. You want to explain, for example, if you're looking at energy efficiency, you want to explain the impact of global warming. You want to explain the bigger picture to allow the reader to understand that what you've done really matters. So if you look at driver behavior sensing, you want to explain many people lose their lives yearly because of bad driving. So that's really the idea with this background. It's what's going on in the world, or what's going on in the region, or what's going on in general that makes this project worthwhile, that makes it interesting and worthwhile. That's the background. After the background, you want to focus in a bit. So from the broad context, you want to zoom in, and there you want to then specifically say, what is the problem that you are addressing? So the second thing you want to highlight is the problem statement. So now you've given the background, you've given the broad context, you want to zoom in and say, okay, in this bigger picture, this is the problem that is left unresolved. This is something that we want to address to help within that bigger picture. So in this problem statement, I've also seen this called a research question, but typically that is more in master's skripsies and in PhDs. If you do a research type skripsie, then over here in the research question, you will state the research question. This sentence is the most important sentence of the whole report. It says exactly what you have done. Nothing more, nothing less, with the right words. This is what was supposed to be done. All right, so after the problem statement, which is typically just a sentence or two, then you have the objectives. So the objective says, if I meet the following things, objective 1, 2, 3, 4, maybe just one if you want, if I meet these objectives, if I do the following things which are observable, if I do them, then I will have addressed that problem statement, or at least a part of that problem statement. By achieving these objectives, I am addressing that problem statement. By achieving these objectives, I'm answering a research question. All right. So you can have 1, 2, 3, 4, 5 objectives. You can have sub-objectives if you really wanted to. I've even seen people put requirements in here. The important thing is that this is what you will be measured against. So in the final chapter, in the conclusion, you'll have to show that you met these objectives by looking at the metrics, the way that you measured, and the results. All right. So after the objectives, you typically have a summary of work, or you can also have here maybe a contribution. Now, for a skripsie, the chances of you having an actual contribution is so slight that it doesn't really make much sense to even mention summary of work, rather contribution. But the summary of work is there so that your reader knows this is what you achieved. So even before they look at the rest of the paper, the rest of the skripsie, the report, they know this is what you claim to have achieved. So all they have to do now is go through the document, have a quick scan through, and see that you didn't lie, essentially looking for the evidence. But at this point, your reader must already know this is what was achieved. All right, so after reading chapter 1, they should have already decided that pending that you managed to prove that you did this, you're okay. So after the summary of work, you include something called scope. And the purpose of the scope is to essentially say what you didn't do. So if you, for example, developed a water quality sensor again, then the scope will say, I did not take into account organic material. I only looked at nitrates. Or, for example, I didn't consider the fact that this thing needs to be mobile. I just developed it to see that it works. So for a final product that you have to develop to address the problem that you mentioned in the background, you obviously have to consider many things like cost, manufacturability, size, the market segment. We don't look at all those things. So the scope section here is to limit what you are looking at. So essentially it's not really saying what you did do, it's more saying what you didn't do, but you want to write it in such a way that it's positive, that it rather says, this is what I did do. All right, but that's the scope. It's important because you want to show to the examiner that you did think about all those other things, even though you didn't include them in your design. It's stuff that you realized were important. Then finally over here, you have a roadmap. And in the roadmap, you say in chapter 2, I did the following, chapter 3, I did the following, and chapter 5, I did the following. Right. Then let's move on. So in chapter 2, sorry, I forgot to say something. The extra requirement that you're meeting here is to say, I took a vaguely or an ill-defined problem. I understood what I need to do to solve it, and then I solved it. All right, so it's about meeting that requirement. In chapter 2, which is typically your literature section, it has a twofold purpose with skripsies. The first one is to say, what did other people do to solve the same problem? So which other solutions exist, and this could be from academia or from industry, which other solutions exist that try to do exactly the same thing? So in this case, I usually tell my students to split this up into 2 sections. The first section will be related work. And this related work is then a summary of other solutions. And for each one of those solutions, you want to essentially capture the following. You want to essentially capture what the other solutions' objectives were, because it's not necessarily the same as your objectives. It could be a related objective or something that looks vaguely similar to what you've done. What were the objectives? Second thing you want to capture is what method did they employ? So how did they go about doing this thing, or measuring this thing, or validating that question? And then what were their results? And then finally, what were the shortcomings, if there were any? So what did they not do that they should have done to address your specific problem statement? If there aren't any, then so be it. Then you say they addressed everything, but you just want to duplicate it. Preferably you want to highlight some shortcomings, or some problems with their approach. For example, we're sat here in Africa. If the solution is not adequate for an African context, you want to here say, that thing won't work here because of X, Y, and Z. Okay, so remaining challenges. The second thing you want to capture in section 2 is what information did you draw from that is needed for your examiner, or that is needed to answer your question. So what information did you draw from? What did you acquire to solve this problem? And typically this information is stuff that you didn't learn in E&E engineering. So you want to demonstrate that you can absorb information from other sources. You're supposed to show that you as an engineering graduate was able to learn from something additional to just your undergrad studies. So over here you want to capture, for example, if you're doing a water quality sensor, you want to capture things like UV spectrum. You want to capture things like optical sensing, maybe things like the color spectrum and how to move signals about in the color spectrum. Yeah, that's the idea. So depending on what you did here, you want to capture additional technologies, and specifically you want to capture information that you will require in the next section. When we get there, I'll show you, to do your design. So if you're going to do anything that's beyond the scope of E&E engineering, that your engineering lecturer may not know or the engineering examiner may not know, you want to include it here as, hey, you need to know this before you can examine it. Or the other part of looking, or the other way of looking at that is, I needed to know this before I could address the problem. And that's again an X outcome that you're trying to satisfy. So the next one, chapter 3. In chapter 3, this varies quite a bit, okay, but let me give you the generic approach. In chapter 3, you have a system design. And in the system design, you want to capture the functional blocks of your whole system. So I typically tell my students to start off with a system diagram. So just draw functional blocks and all the functional blocks in your system. And then for each one of those, you want to say, what is the purpose of that functional block? So you make a section 3.1, whatever this thing is, thing 1. Then you say, to do thing 1, so let's say it was to do optical sensing. To do optical sensing, I could have used an LDR, I could have used a photo transistor, I could have used a CMOS sensor, for example. You want to list the options that were at your disposal. Now, importantly, in order for you to make this choice, you had to introduce the reader to the background information in section 2. So it flows nicely into section 3 where you make the choice. I had to choose between 1, 2, and 3. I chose the following for this reason. It's very important that you describe here, I chose this for this functional block for the following reason. All right, so you don't go into the level of calculating resistor values, calculating very minute detail. You almost choose a technological option in this here. So you fill your logical functional blocks with a bit more color to help the reader understand how you set this whole thing together. So when you draw this functional block, you want to say there's a microcontroller here. You want to say there's a sensor here. There's an actuator here. There's a power conversion here. There's whatever there is over there. And then importantly, what I also tell my students to do is just put in, this is the interface between the functional blocks, like a UART or an I2C or a 5-volt signal, or etc. So typically on the system diagram, you have the functional blocks. You give an indication of how the power flows work. So 5 volts, 12 volts, there's a converter here, ground that goes here, and then just what each functional block consists of. So you can either have, in that first system diagram, you can capture the whole system as you are going to choose it. So you can fill in the blanks already. You can say LDR here if you wanted. And then over here, you just justify the choice, or you can have two system diagrams. The first one just says, generically, this is how the functional blocks look. And then you repeat that functional block diagram at the end, where you specify what you put into each one of those blocks. That's the system diagram. So for each one of those blocks, you have a section. Another very important section here is your metrics. Metrics. The metrics section says, I want to measure whether I meet the objectives, and this section tells you how and what am I going to measure. So if you wanted to, for example, develop a water quality sensor, you're going to have to check, does this thing respond to nitrates in the water? Does it have variance, or does it have a proportional response to an increasing concentration of nitrates in the water? And then also you want to check, does it not respond to organic material, for example? So won't it give false positives? So over here in this metric section, you list what do you intend to measure, and how do you intend to measure? It's almost like an experimental setup, if you want. What do you intend to measure? How do you intend to measure it? So physically, I'm going to measure this with an oscilloscope, or I'm going to measure time. I'm going to measure voltage. I'm going to measure light intensity over a range. You specify that here in metrics. And again, it's very important that these metrics tie up to the objectives that you set. So these are the objectives I want to meet, and these metrics show that I met those objectives. And as I said, I've seen people put requirements in that objective section. I've also seen people start chapter 3 with a list of requirements where they take those objectives and convert it to requirements. But again, then these metrics need to directly match up to those requirements. So each one of the metrics must prove that you are meeting the requirements. If your skripsie is more of a research question type skripsie, then over here you would call this chapter the methods chapter. And you can call it methods as well here, but typically the skripsies are a bit more designy. It's more like make a product. And in that case, it makes more sense to say this is the system design. But if you have a research type skripsie, you may call this the method, and then you explain the experimental setup that you go through to answer that research question. Right, the next section, the next chapter would be the detailed design chapter. So in the detailed design chapter, you have to specify for each one of those functional blocks, how did you go about designing the minute detail of each one of them? So what I typically tell my students is just mirror those functional blocks that you had in section 3. So 3.1, thing 1, you map out that this is where you describe how you filled the functional block. So I chose to use this type of technology. And over here, you then go and calculate the resistance values. You calculate the sensitivity. You calculate the capacitors. So over here, you do the detail hardware or the detailed software design of this functional block that you chose. So for example, if you had a software skripsie, over here you chose, I want to use a Mongo database. That's the technology I chose. Over here, you'll explain how did you set up the Mongo database so that it meets the requirements. But over here, you choose the fields in the Mongo database. Over here, you choose Mongo, and you explain I had the option of a SQL database, a Mongo database. I chose a Mongo for the following reasons. All right, so this is just design. You don't give any results unless there are intermediate results. So let's say you wanted to just do a quick look-see. You just wanted to check, does the resistor get too hot, or I don't know, some quick check. Then you can put the result here, but preferably your results go in a separate chapter, the results chapter. So in the results chapter, you do not give any design. You do not give any justification. You do not go into any level of requirements or objectives. You just dump the results, and the results are supposed to match what you specified your metrics will be, and the results just reflect what happened when you use those metrics. So in the results section, you have figures, and you have tables, and you have text. Now importantly, each one of these figures must have a caption. This must be a descriptive caption. So when you look at the figure, read the caption, you must understand what you're looking at. And what you do for each one of these figures in the text, you say, what is it that you're showing the reader? So you say, in figure 1, we are looking at the response of doing this when we do this. So that's this first sentence. What are you looking at? Second sentence you want to include there is, what is it that you're showing the reader? So you said what they're looking at. They're looking at a measurement of temperature when the sun shines. Then you say, when we look at this, we can see that the temperature peak is in the middle of the day. So first you say, what is it that you're looking at? Second thing is, what is it that you're observing? So what are you taking from that image or that figure? The third thing you're doing is you're saying, so now that I've seen that, I've observed that strange behavior, or I've observed that expected behavior, so what? What does it tell you? I'm seeing that there's a peak in the middle of the day. My sense is working. Or I'm seeing that there's a short burst of current when I turn it on. Not what I expected. Something's wrong. I needed to fix it. Or it will have to be fixed in the next iteration round. I'm really sorry. All right, so that's important. So what are you looking at? What are you observing? And then what do you take from it? And that you do for each table and each figure. And all of this body of results must then correspond to what you said you were going to measure. And importantly, that must then directly address the requirements and or the objectives that you set. Finally, you have the conclusion chapter. And in the conclusion chapter, you first just say, again, just a quick repeat for the reader. This is what we try to do. This is what I gave in the whole of the report, just a broad overview. And then what I typically tell my students to do is list objectives, objective 1, objective 2, objective 3, and say, I used this metric. You can even put in the reference to the section if you want, and I got the following results. So as shown in figure 4.3, I showed that I met this objective. Then after you've met all the objectives, you have a conclusion as in, so what? So what do you take from this? So now that you've met all the objectives, what can you say? And this section here mirrors directly back to chapter 1's background and problem statement. So now that you've shown that you met the objectives, the question is, okay, so what? What are you going to tell your granny if they ask you, what did you do? Well, granny, I made a water quality sensor. And she would say, oh, really? That's fun. So what? And then you have to say, okay, granny, now this means that people in rural KwaZulu-Natal who don't have access to clean water can use this sensor to do the following, but with the important caveat that I found more work needs to be done in the middle of the day, or something silly like that. And the only other thing that's left is in the conclusion, you also typically have future work or recommendations, and that's about it. So that's more or less what goes into a skripsie report. I hope I didn't forget anything, and hopefully that's fairly useful to you.